Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create a counter for conveyor belt. So what is the scenario? Scenario is basically we have here a conveyor belt, and on conveyor belt we have boxes which basically moving. So we are going to detect the boxes. Also we are going to create the counter for boxes with the help of Raspberry Pi 4, Raspbian OS Bullseye 64-bit version. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, for today we are going to create a RPi4 conveyor belt boxes counter. So this is the repository. I will mention the link inside the description box. You need to simply copy paste the link inside the browser, then go to the code, click on download zip, and it will download a zip format repository. So just go here, click on show in folder. This is what our repository in zip format. So just right click, click on extract here, and it will extract our folder. So first we need our video file. So vid.txt is basically the text file, and inside that text file we have our video file link. So this is the link, copy it and just open new tab and paste the link, Ctrl+V, and just hit enter. It will open our cloud link where we have our video file in zip format. So as you can see, this is what our link. So simply click on save, because I have already downloaded the file, that's why it says save. You need to simply click on download button and it will download our video file. So just click on download button. So again go to show in folder, downloads, and this is what our video file in zip format, the box6.zip. So same way, right click, extract here, and it will extract our video file. As you can see, box6.mp4. So just right click, cut, and just paste the video file in our repository. That's it. So now what we are going to do, we are going to move our repository on main folder, means /home folder. So just right click, cut, go here, home, and just paste it. Done. That's it. So minimize the browser. Now let me first start the video file, then you will get the idea what is basically goal. So this is what our repository, and this is what our video file. Right click, VLC media player. So friends, as you can see, this is what our scenario. We have here a boxes which basically moving on a conveyor machine. Okay, so and our target is what? Our target is we need to detect the boxes. Also we need to create a counter for boxes. So this is what our scenario. So first we need to detect our object, means first we need to detect the boxes, and then we are going to create the counter. Okay, so this is what our scenario. As you can see, the boxes is continually moving on the machine. So for that, what we are going to do, we are going to use here simple color tracking method. So track.py. So just open Thony Python IDE, go to the menu, programming Thony, and this is what our Thony Python IDE. Go to the file, click on open, and first we need track.py, okay, which basically track the color, and then we need our main code, which is counter box test. Okay, cbox_test.py. So cbox_test.py, this is what our main code. So here it is. As you can see, I have mentioned our video file already. So and here if I scroll down, the one more thing, because we want to track the color. For that I have mentioned here time.sleep 0.1 millisecond. Simple. So if I start the code, the track.py for tracking the color. So as you can see, this is what our main frame, this is what our mask frame, and this is what our track bars. So here it is, as you can see, the video is playing really slow way because we want to detect the color. So HSV, this is the lower value, lower H value, lower S value, lower V value. This is the upper H value, upper S value, and upper V value. Simple. So let's just start with lower H value. If I move this way, as you can see, as you can see, the boxes is completely masked. So we don't want to move the H value. The H value will remain same, the 0. Let's just change the S value, the lower S value. So make like this way, and as you can see, all other things are basically masked. Okay, it's now really good. So it's good. Now as you can see, we only see here, we can see here we have only boxes. Okay, boxes, the other things are basically masked. Now the V value, the lower V value, just move the track bar like this way and check in the result. Okay, check in the result and mask. Okay, so let's say no, this is good. Okay, as you can see, because our goal is we only want to detect the boxes which moving on. So here in this track bar's position, we can see we have detection, means we can see we have boxes, we can see the boxes is moving. Okay, and other things are basically masked. So this is the perfect value, this is the perfect lower H, lower S, lower V value. So 170, not 179 friends, this one, this side, the 0, 46 and 64 is basically our lower H value, lower S value, and lower V value. Now upper H value, upper S value, upper V value, just move upper H track bar and just watch in the result. Okay, the all is good. Now it's completely masked, so I think this is perfect. These small boxes also we can detect for this track bars values. Okay, now the upper S value, just change the track bar, just change it, no, so just back, and here we have perfect detection. And then the upper V value, just change the track bar. Okay, now go back, and here we have perfect detection. As you can see, we have perfect detection. Okay, as you can see, the box we can see clearly. So this is what our lower H value, lower S value, lower V value, upper H value, upper S value, upper V value for particularly this scenario. So we need to mention these values. So lower H value 0, lower S value 46, lower V value 64, upper H value 43, upper S value 115, and upper V value 160. So we need to mention this value inside our main code C box test.py. Here it is, as you can see, I have mentioned the lower range and upper range. So we need to simply mention our track bars. So lower H range is basically 0, so 0 is there. Lower S value is 46, so let's just mention 46. Then we need lower V value is basically the 64, so let's just mention 64. Then upper H value is 43, as you can see, 43, so mention it 43. For upper range 43, then we have 115, so here we need to mention 115, and then the last one 160. Okay, so 160, that's it. So just save the code and stop our track.py. We have done. Now what we are going to do, with the help of the lower range and upper range, the color value, we can simply detect our boxes. Okay, so first just start with basic code. So let me comment some advanced things. Okay, so here I am going to comment these things. Okay, so because right now we only want to detect first our object, okay, then we will move for the counter. Okay, so let's just, because I have mentioned full code, but for explanation I will comment some lines for basic thing. Okay, then this thing also. Now we only want here cv2 circle method, cv2 rectangle method, and there is no need of put text method. Okay, that's it, we have done. Now if I save the code, so let me explain the code first. Import cv2, of course we need to install opencv-python. So just go here, tools, manage packages, and just search for opencv-python, opencv-python, click on search on PyPy, opencv-python, and then click on install button, and it will install opencv-python package. Then we need a cv zone for put text method. So cv zone, just hit enter, click on cv zone package, click on install button, and it will install cv zone. That's it, we have done with package installation. So import cv2, import numpy as np. Of course we are going to use here a tracker for object tracking. So we need to call our tracker. So inside repository I have mentioned the tracker.py. Okay, so file, open, and the tracker.py. So it will track our object and it will assign the ID for each object. So this is the tracker.py file, tracker.py, and simply we need to call our tracker.py file in our main code. So that's why I have mentioned from tracker, our file name, we need to call all these things, import all from tracker. That's it. Then we need to call our video file. Then this is what lower range and upper range, which I have already shown you how you will get the range with the help of our track.py code. Simple. Then this is the method, this is the function for mouse point. For mouse point, so when you move the cursor on your frame, you will get the mouse point, means you will get the cursor point. Then tracker is equal to tracker, this is what our tracker. So tracker is variable and tracker is basically our tracker. As you can see, the class, the tracker. As you can see, the T is basically in capital. So here we are going to simply call the class. So tracker is equal to tracker. cv2.name window RGB. So this window is basically for our mouse pointer function. Okay, cv2.name window, and the window name is RGB. Then cv2.set mouse callback function RGB, and our function is basically RGB. So I have mentioned that function over here. With the help of this function, as I mentioned, we will get the mouse points, means we will get the mouse cursor point, which when we move our mouse cursor on the frame. That's it. Then this is the area. Okay, this is the area points, but let's just go with basic code, then I will explain the area. Then this is the counter, next things. Then while loop, read frame cap.read, this is how we will read our frame. Then frame is equal to cv2.resize method. Of course we are going to resize our frame because we are working on Raspberry Pi 4. So 640 and 480 is the perfect frame for Raspberry Pi 4. Also for this scenario, then we are going to convert our frame in color BGR to HSV format. As you can see, I have mentioned cv2.color BGR to HSV format. Then we are going to use mask is equal to cv2.inRange SSV and lower range. So what is our lower range? This one, lower range and the upper range. Okay, as you can see, lower range and upper range. Then we are going to use here cv2.threshold method. So mask1 is equal to cv2 dot threshold mask 254 255 cv2 dot thresh binary function. Simple. And then we are going to use a contours method. So contours is equal to cv2 dot find contours mask1 cv2 dot return external cv2 dot chain approx none. Basic thing. Okay. Then of course we are going to use for loop for counter. So for c in cnts x is equal to 500 if cv2 dot counter area c, if it is greater than 500, then we will detect the x, y, w, h coordinate. Simple way. So x, y, w, h is equal to cv2 dot bounding rectangle, and inside that simply we need to pass our c. That's it. Then we need our tracker, of course. So for that, inside the tracker we need to pass our x, y, w, h coordinates. So how we can pass? Simply we need to create a list. So here it is, as you can see, list is equal to empty, and here I have mentioned list dot append, and inside that we need to simply pass x, y, w, h coordinates. That's it, as simple as. Then now we have our coordinates inside the list format, so simply we can send our coordinates with the help of list to our tracker.py. So bbox idx, just a variable, is equal to tracker.update, because we have inside the tracker we have update function. So for that we are going to use our tracker like this way, bbox idx is equal to tracker.update, and inside that we need to pass our list. Okay, so far so good. We use here bgr to hsv method, then we use here cv2 dot in range method, and inside that we pass our lower range color and upper range color coordinates. Then we use here cv2 dot threshold method with the help of cv2 dot thresh binary function. Then we use a find contours method and cv2 dot chain approx none, then cv2 dot return external, basic thing. And then for c in cnts, x is equal to 500, this is the value, and if cv2 counter area, if it is greater than 500, only we want to detect our object, we can say, simple way. So then x, y, w, h is basically the coordinates for drawing our rectangle, cv2 dot bounding rectangle method, bounding rect method, and inside that we need to pass our c. Simple. Okay, then because we want to create a counter, so we need to send our x, y, w, h coordinates. So what is x, y, w, h? X, y, w is basically our object coordinates, means when we detect the object, of course we are drawing their rectangle on each object. So our object is basically our rectangle. So x, y, w, h coordinates we want to send to our tracker.py. Then with the help of tracker, again we will get the new coordinates for drawing rectangle. Also we will get the ID. It will assign the ID for each box. So for that, bbox idx tracker.update, and we need to pass our list. As I mentioned, now we will have again new 4 coordinates with ID. So for bbox, in our bbox idx, we will get the new coordinates. So x1, y1, w1, h1 and the ID, and this all basic our bbox. And then of course we need a center point of each box. So cx is equal to int x1 plus x1 plus w1, x1 plus x1 plus w1 divided by 2. Then cy is equal to int y1 plus h1 divided by 2. That's it. This is how we will get our cx and cy. Simple. Now we have cx and cy, we have a rectangle coordinate, simply we can draw the rectangle. So this is the basic code. It will detect our object. So if I start the code, and as you can see friends, we are detecting the box. We're detecting the boxes which basically moving on conveyor belt machine. Okay, as you can see. But what is our goal? Our goal is we only want to detect the boxes which basically on the machine, on the conveyor machine, on the conveyor belt machine, we don't want to detect other boxes, okay, other area we can say. So for that we need to mention here a particular area. Okay, so let's just watch the frame. For that we have a center point. So let's say if we draw here somewhere here a polylines, if we draw here somewhere here polylines, and if we say we only want to detect the box if the center point of box, if it is inside our polylines, then only we want to detect the boxes, otherwise we don't want to detect the boxes. For that we need to draw the polylines. So simply for that we have here a mouse function. As you can see, if I move the mouse cursor on the frame, inside shell we have x, y coordinates. As you can see, because I am moving mouse cursor continuously, that's why inside shell we have a mouse coordinates which continuously changing. So let's say if I want to draw here a polyline, so I need to simply move my cursor over here, and 294209, this is the first coordinates for drawing the CV2 dot polyline. So as you can see, this is how I have mentioned the area. So 391244, 370443, 391438, 410237. This is basically our polyline coordinates. As I mentioned, simply where you want to draw polylines, simply move the mouse cursor over here. So this is what my first point, 327235. So this is what my second point, 337369. Let's say this is what my third point, 391361. And if I want to go here, so this is basically 365 and 186 inside the shell, as you can see. So this is how I have mentioned these coordinates. Okay, I hope you all clear. So if I save the code, so we have our area. Now simply I want to start CV2.polylines method, and it will draw the polylines on our frame. Okay, so let's just freeze our frame first. So mention 0. If I save the code, if I run the code, now you will see the polyline on our frame, and as you can see in white color, so this is what my polyline, or we can say this is what my area. So if this box center point, when it come inside our area, then only we are going to detect the bounce, then only we are going to count the box. Okay, so for that we have function which is this one, CV2.pointPolygon_test np.array area np int 32. This is the area. This is what our area. This is how we draw the polylines. So what I have mentioned, when the box center point, if it is inside our area, so box center point is basically our cx and cy. So here it is, as you can see, inside CV2.pointPolygon_test method I have mentioned cx and cy. So the cx and cy is basically the center point of our box, and the area, the polylines area, is basically this method np.array. So just copy it from here and just paste it like this way. Okay, so what is the meaning of CV2.pointPolygon_test function? This is the area, and if our center point cx and cy, if it is inside this area, then we want to detect our object. Simple. So result is basically if result is equal to or greater than 0, this result, okay, this result, it is greater than or is equal to 0, then only we are going to draw the circle, then only we are going to draw the rectangle, let's say. Now if I save the code and I need to start the while loop, if I save the code, if I run the code, now you will see our, as you can see, now there is no detection in other side. When the box center point come inside our area, polyline area, then only we have detection, then only we have object detection. Then we detect our box, which is basically moving on conveyor belt machine, as you can see. Okay, as you can see. So we successfully detect our object in particular area. Now we are done. Now we need to create a counter. So simple. What we are going to do, because we have our ID. So now if I start the CV zone put text method, and here I have mentioned the ID. So it will assign the unique ID for each box. So I need to save the code, and if I run the code with the help of tracker, because we have ID, so when our box center point enter inside our area, as you can see, this is what our ID. This is what our ID for this particular box, for this box. For this box we have 24. So it will basically assign the unique ID for each box. Simple. Now we can simply create the counter, because here I have created a counter is equal to empty list, and counter is basically what? Counter is basically the ID. So simply we need to mention here if counter.count ID is equal to 0 and counter.append, we need to pass our ID, and it will save our each box ID inside this counter list. Simple. Now let me first comment this line, if counter. Okay, and what we are going to do, simply now we have the ID, check it is in line. Okay, we have the ID inside our counter. So here just print the counter, just print the counter. If I save the code, if I run the code, now just watch inside the shell. As you can see, 11 11 11 11, it means this box ID is basically inside our list. So 11 11 11. Now the next box is coming. "24 24 24". But what is happening here? It's counting same ID again and again. So for that we want to create here if condition, and in if condition we want to mention please don't count same ID again and again. So if counter.count ID is equal to 0, then only we are going to append our list. And now if I print the counter, as you can see, right now there is nothing, the list is empty, and we have 11. Now as you can see, it's not counting same ID again and again. So we have only count one ID, which is 11. Now the next ID 24. Now simply if we want to create the counters, we need to mention like this way, the list length is basically our counter. So here I have created C1 is equal to length of our counter, then we will get the counter. So now I am going to put our counter on the frame. For that I have mentioned CV zone put text rect frame C1 and 1560 is the coordinates. It will put our counter on the frame. That's it. If I save the code, if I run the code, and as you can see, right now the counter is 0, 1, we counted one box, so friends, as you can see, we are successfully counting the boxes. So we create here object detection, also the counter with the help of Raspberry Pi 4. Okay, so I hope you will learn something from this video. We will meet our next video. Till then, thank you, take care, and bye bye.